All right, hello everyone. It's December 25th. All right, we have a basic calculator. It's an old question. Let's take a look. I don't remember. I don't think this one was one of the ones they did last time. I just said that and it was. Wow, I submitted many times. Okay, that's a big difference. Okay, given a string s, which represents an expression, evaluate it and return its value. Integer division should truncate toward 0. What do you mean by truncate towards 0? You assume that a given expression is always valid. Okay, you're not allowed to use any built-in function such as evaluate string. I think one of the methods I use is eval. Okay, so this one will be 7. This one will be, okay. This one will be 2, 5, yeah. Consists of integers and operators by some number of spaces, such as a valid expression. Wait, hold on. Is there parentheses? Nope, there's no parentheses. Okay. All the integers in an expression are non-negative. So no negative value, no parentheses. Okay, so let's think. Order, right? That's basically the thing. We're talking about the order. So 3 in, right, plus in. So when we see a plus, we don't get too excited. And then we keep push 2 in, and then multiply. Okay, that is something you need to be interested in. Multiply, right? And then you push 2. How do we know which one to pop out? I mean, what we can do is using recursion to do this, right? So 3 and then plus. Anyways, as a number, I push it in, and then plus sign push in. And once we have a plus sign, now we know it has the plus whatever the remaining. So the remaining we're gonna do a recursion. Okay? So in this case we have 3 pushing the stack plus, actually do we need to push in a stack? Yes, so we push into a stack. And then the remainder we're gonna call this. Okay, so we're gonna solve this question in the recursion. And inside the recursion, the same thing. So 2 is in the stack, multiply, okay. We're gonna say the current operation is multiplication, right? And we can we do that? Well, if it's plus sign, because if it's a plus, we can always add parentheses to the end. It doesn't really matter, right? If it's a plus, we can add parentheses, or if it's a negative, it doesn't change anything. Okay, so if it's a times, but if it's a times, we cannot just add because times has precedence. So if it's a times, then if it's a times, then the next value would definitely be used because there's no parentheses, right? There's no parentheses. So if it's a times, the next value would definitely be used. So if we see a times, we just keep reading, right? So times, pushing in, we keep reading a value, and then with a value, we'll look back into the stack, and then we see it's a times, so we produce a new value and push into the stack. And once it's over, we're going to return whatever is in the stack. So it comes out. Okay, so when it come out, I see previous is a plus. Hold on, if I see something plus, and then the remaining value, we can't just put a parentheses around. We can just do whatever the remaining is. It won't change anything. If it's a minus, we can do the same thing, but whatever is inside needs to be changed. Like the sign needs to be changed. Well, if it's a minus, if it's a 3 minus 2 plus 2, right? So we can do minus, and then we do this, and all the plus sign will turn into a minus sign. That's fine. We can code that. We can call that. So that's the minus part. And if it's a multiply or a division, when we see it, we immediately produce a value. And eventually, there should be only one value in the stack, and I return it. And if it's a plus or a minus, we do whatever is the remaining, and then we will produce a value. So the difference between the plus, minus, and the multiply and the divide. Now, multiply and the divide is the same. So when we see it, we immediately take the next value and then produce a result, because there's no parentheses. Plus and minus are the same. When we see it, we immediately take the remainder expression into the recursion, right? We recurse on that, and then when we get the value, and then we produce the final value. So that is also okay. Okay, so I don't see the point of having a stack. All we need is just a variable to save the first value, right? Let's see if we can code it up. I mean, I better code it up. I did it last year. I should be able to do it this year as well. There's no reason why I cannot do it this year. All right, so here we go. All right, so what are we looking at? So we're looking at a def helper, right? So a helper, we're gonna go with index, right, as an int, and this one will return an int, blah blah blah, and then what we're gonna do is call return helper 0, right? Okay. So what we're gonna do is we're gonna find the first integer. Okay. So what are we going to do? We'll find the first integer. And find the current operation. So I have the integer. So I have the operation, and if it's a plus, then we just return this. If it's a minus, we'll return this. And if it's multiplication, then we find the next one. We keep going. Okay. So we can also say reversed. I'll just say rev is going to be Boolean value, so it'll be false when we come in. Okay, so now what we're going to do is the left and operation equal to left is 0, there's nothing, and operation is going to be this, is nothing. And we can say op operations will equal to, all right, plus, I can do import operators. I mean, this should be, is it operators? Operators. Should be operators. Yeah. Operators, not operators. So operator.add. So this one will be operator.add. This one will be operator.minus. Subtract. Sub. This is a multiplication. Mole. Operator on mole. And divide. Here's divide. Here's division. Floor division. That's what we want. Floor div. Floor div. Yeah. So operator. This one will be operator floor div. Okay, so that's operators. Okay, I'm going to say for, I don't know, for I in range from index to len s, right? And then we say if 0 smaller or equal to si smaller or equal to 9, right? Then left equals 10 times left plus int si. So we're doing this. Else, this is when we hit an operator, right? So when we hit an operator, then we're going to check, which means it's aleph si is in, as si is plus sign, right? If si is a plus sign, then we're going to return left plus, I don't even need this. I just say left plus helper. I is I plus 1 is rev, right? Aleph si is equal to a minus sign. Then we return left minus helper I plus 1 not is rev. And then we have to handle this, right? So if it's a plus sign, then we have to also check if is rev, right? Oh, hold on. If it's a plus sign, right? And then if we need to reverse, then this is going to be not plus, it's going to be minus, right? And the minus something because it's, and then is reverse. So basically, if it's a plus sign, we're going to maintain the same, but there's going to be minus if is rev, else left plus helper I plus 1 is reverse. So we don't change it reverse. However, if it's this is reverse, then we have to go a plus sign, right? And if it's a negative, right? If is reverse, hold up. No. If it's a plus sign, right? If it's a plus sign, then I am facing a minus. I'm minus something. So is reverse is true. Ooh, hold on. The question is, shall we reverse the inside? That's the problem. Shall we reverse the inside? So, okay, if I am plus, and if reserve is false, right? Else, it's just like we don't reverse, so it's still gonna be plus, and the remaining is not gonna be reversed. So this is gonna be true, right? But if is reverse, no, if reverse is false, right? So we don't reverse. But if reverse is true, so previous is minus something. So I come in and have to reverse, right? So inside this, it has to reverse. And I'm a plus sign, so I need to reverse to negative. So it becomes, so if you think about inside, it's something minus something, right? And then the original is already reversed once, right? Original already reversed once. And I put another parenthesis on it. Then we reverse back, right? Reverse back. So basically it means there's no reverse. Yeah, it's like two reverse. Was it? Because now it's plus something, right? But this plus is the reversed version, right? So if I go negative, and then this shall be false, no reverse, because I already reversed on the outside, right? So this is because there's no reverse on the outside, so plus sign, no reverse on the inside. This is, we have a reverse on the outside. Outside is negative, so inside I'm a plus, so I have to swap to negative, and all the plus need to swap to negative, and then I got negative, and I got a parenthesis around it, so all the negative need to switch back to positive, right? Or all the negative become positive, switch back to negative. So there's no reverse here, right? Okay, so now I'm looking at a minus sign. If reverse, so if reverse, now what I see is a negative sign. This is what I see, right? This is what I see is a negative sign, but it's got reverse, so it become plus, right? It become a plus sign, which means inside no longer reverse again, but because on the outside we have reverse, so this has to be reversed as well. Else, which means there's no reverse, then left minus helper, right, I plus 1, and true. There's no reverse on the outside, but I'm a negative sign, so I have to reverse again. Okay, so that's that. I love else, which means it's multiply or division, right? If it's a multiply or division, then what do we do? Well, it's a multiply or division, so we just simply keep going on, but now it's going to be right? Hold on, let me think. How can this be? That's just a current number, right? That's just a current number. And we just need to current number. Hold on. I need left current, okay? And every time this one shall be current, right? So this is just do the current. So current, blah, 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 blah. And once it hit a plus sign, so current. Now I hit a plus sign, right? I hit a plus sign, then we need to see we're always going to do left. I don't like it. I don't like it. I still like left, and I'd like to do it this way. No, index. While I smaller than linus, I like to do it this way. Okay, so if it's blah, elif, elif else. Okay, go I plus equal 1 here, right? And blah 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 else what? Else, that means it's a plus or then we do we need to read another value while I smaller than ln s, right? And then we say right or equal to 0, and we do the exact same thing here. Okay, so do the exact same thing, and we just do right blah blah blah. Once they come out, then we have a right. I'll have a left and right. Then, oh, hold on. So if this else, when they say OP will equal to SI, right? That's the operator. That's the operator. And we keep moving forward. Now we have the operator. Is a okay. So now I have a left and right, and then what we're gonna do is just say left will equal to left multiplied by right if operator is equal to this, else left divided by right. And always good habit, put extra parentheses just to make sure. And sometimes this can be confusing. Okay, so we now get a new left value, right? And once this is done, so I smaller this, if it's blah blah blah, if it's so if it's this, we do this, I put equal to 1, else break here, right? Else in the break, and I is pointing to, then come back up. Okay, so this one eventually going to return left, which is not these cases, but just these cases. Yeah, so we do this and eventually return. And in this case, we also only need to have this, so all the len can be replaced by n. Okay, I was trying to see if it's possible to combine. Left and current. What if I have a left and current? So the current is the new value. So the current is, okay, current, and we hit something, that's going to be left, right? And then current will return to 0. And then we check, okay? And if it's this, we do this, this, we do this, it's like normal. And if it's not, it's in the multiplication, then I keep it and go back, blah, 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 blah. Once we hit a not, then we check the OP, right? We check OP. And if OP is this or that, then we update left. If OP is, and OP when they return back to, hold on, maybe it is better to have this setup. Let me see, what's in mind? So for I in range n, not n, index to n, right? So what are you thinking? I'm thinking is, if this, right? If this, then it's not going to be left. It's going to be current, right? And then else. And OP equals this, right? Okay, no, not yet. else, and we check if OP is equals this or OP equals this. So if we have an OP already, right? We have an OP already, that means we have a left already. Then we do this, right? Then we do this. Left equals left times, and this is not right. What I have is current. So if OP is this, actually, it'll be easier. If OP is this, then left multiply equal to this, right? Now if OP is this, let me say left equals current, right? And else. And in both cases, once we're done, OP is going to be back to this, right? So if it's this, do this. If it's that, do that. Nah, I feel like this is, no, I don't like it. Too many lines, man. I like this way, but let's say OP in, right? If OP in this, then we update left. And after updating, OP is equal to this, right? No, it's not right. Current. And then we reset this. So and then we hit a new operator. Right, this side is a new operator. And then if we have previous operator, we turn this. Now we have a new left. Now we're gonna handle the new operator. Right, handle the new operator. Okay, now we're gonna handle the new operator. So now we have a left. Right, we have a left and a current. In this case, we don't worry about the current. So I think current needs to reset to 0. That's if OP is in this, right? Otherwise, right? Otherwise, so what this do is we just update the left, right? Now we're gonna say OP is equal to, well, that depends, right? That depends. That depends on if so we do this, we get an updated left, all right? We get updated left, and we can do this, plus or minus, right? That's a thing we need to taken care of. We say if this is plus, then we do this, and then we just return it. Immediately, we're done. Otherwise, if it's a negative, we do this, then we're done, right? Then we're done. Else, right? Else, the current one, then OP is equal to current one. That was plus, multiply or divide. Now, in this case, we just do this, right? And which basically means we don't need this line as well. We can just do it here, right? So we don't need this line. We can just say OP and current reset here, because these do not reset. So we do this to update the left, right? After update the left, I check the current operator. If it's a plus, we do this. If it's a minus, we do this. And if it's none of these, that means it's multiply or division. Then we reset the operator, reset OP, and we reset current, right? And then in this case, we'll go back up, right, to the next I, which is going to be values again, right? And then you can save all these clutter. And then once we're done, right, because update left is here, and then go up and then we return left. Okay, so that was my case. Okay, let's do this. So we have 3 plus 2 times 2. Oh, you have we're gonna skip. Okay, so if si is equal to this, continue. All right, so we're gonna skip empty spaces. Because if not empty space, we're gonna reset OP. That's else if this is how we do. We can just go if si in this, right? Then we do this, and the empty space would just get ignored. Okay. All right, so this one's 7. Yeah, including the empty space. This one should be 1. This one should be 5. Okay. So this is S. This is calculate. S. Run it. Ooh. What happened? Integer division modulo by 0. That's interesting. How is that possible? And of course, the first one we got it wrong. Okay. Result is 0. Huh? Wait, what? Oh. Let's print. All right, so the idea is current should be 3, right? Current 3, and then this. Oh, I'm doing left. I have current, right? And then if it's this, then we need to, hold on. So we accumulate the current, and then we hit this. It should be, right, when it's not, right, when it's not, that means the number is done. Then we say if OP is in these, in this, it depends on left. Yeah, because left is 0. That is not right. It's the first time. So left shall be, I can set it to a sentinel value. Like none, right? We can set left to none. And we say, coming here, we say if left is none, left shall equal to current, right? And then if I have a previous operator, that means I have a previous left. Okay, if I have a previous operator, aren't you just make things more complicated? No, we need to save the previous operator. So if operator is, that means we have a left. So this is fine. Now the trouble is, so we're gonna go in, current is 3, right? And then this one's plus, we're here. then we say it's gonna be here left plus, so we're gonna go, so when left is 0, right? And plus 2 times 2 now comes in. The first one comes out 2, so current is 2. And then now this, then we do this, and we reset current to 0. So that is the issue. Okay, so operator, this is fine. And these, and we need to handle this as well. How do we handle this? It should be left, right? Because I save it to the left. So I think we have to check the left and the current, all right? Okay. So anyway, so operating this, we do the left, right? Else, this operator can only be this or this. That's the only possibility for the operator, right? So if the operator is this, then we simply say left equals current. That's when operator is empty, right? Is empty. If the operator is empty, then we do this. Left equals this. Okay, and then if the current operator is plus minus, then we do this because it's set in negative. If the current operator is this, right, then we need to set operator. And I can because I set the left already. So let's try this one. This one's still wrong. The heck? So 3, that's the first one. The current is 3. And then the next one, so left equals 3. The SI is a plus sign. So that should be 3 plus something. Now this requires debugging, but I'm kind of lazy. So what should I do? What should I do? I should just check here. All right, print left current and SI and just I and operator. Let's see what we have. So left is 0, current is 3, I is 1, 0, 1. Operator is nothing. That's true. And then we will go in here, right? Then left plus, so 3 plus something. For the second round, so it will be 0, 2. Left is 0, current is 2, operator is 0, 1, 2, 3. Okay. And then operator is not in this, so left shall be 2, right? And then shall be here. OP, this equals this. Okay, so currently SI is this, right? This is SI. And I say operator turns into this. And the current is 0, right? Current is 0. But when I say current is 0, okay, let's do this. Probably easier to see. What? I said the left equals current. How the left is still 0? Huh. Are we inside here? No, we're not inside here. Wait. Ah, that's that issue. Okay, so can I do this one? So we need to say equals this or OP equals this. Okay. And then same thing, equals this or I equals this. All right, so now we get a bit better. So now left and right, so we have 3, right? So now the problem to solve is inside the 2, 2. So 2, current is 2, right? I is 3, operator is nothing. So it will come to here, and operator will be multiplication, current is 0, right? So I'm going to go back up to get a current out. So I see. So it will get out, and then we're gonna say we're gonna do this. Return this. Okay, so that's that. Now I'm gonna try the other 2. Oops. Okay, we have issues. The second one is not right. Okay, it's fine. All right, what happened? Okay, so again, we're gonna put a print here. Again, left current I and operator. So I think it's messing me up. Yeah, I think it is messing me up because operator. Oh, that's fine. Left current is 0. Yeah, and then none of these fit, so I just keep going, right? So the next time I see is 3. 0, 1, 2. 3, and it's gonna be here. So operator. So the next one comes up. Oh, now we have this. Oh, I see. I see. So, oh. Well, I think what we should do is let me see, empty spaces. And empty spaces is just, yeah, I think the best way to handle empty, let's just ignore it. If Si is equal to empty spaces, we just continue. So we don't worry about empty spaces. Yeah, it makes things more complicated. So I just ignore empty space. Okay. All right. Now we have these 2. They both pass. Now handle the last one. Last one pass. Okay. So this one might be correct. So we're gonna just check. We can try something more complicated. Let's say 1 minus 2 times 3 minus 4 plus 5 divided by 6 plus 7 minus 8. Right? I don't know what this one is. That's 6. Right? Yeah, and actually let's do 6 divided by 5. It's 6. So 1 minus 6 minus 4, that's minus 9, plus 1 is 10. 17, 9. I think this one should return 9. Ugh! Did I do it wrong? I actually don't know. Let's say eval. How about eval s? Oh wait. Oh, I cannot do eval s. Technically, I can. Just a double, but it's fine. Wait, I need to. It should be right? 1 minus 2 times 6 minus 4 plus 6 divided by 5, which is 1 plus 7 minus 8. Oh, it's minus 9. My bad. It's minus 9. Alright. Still not right. Okay. That's fine. What went wrong? So basically coming in 1, right? And then we have a minus sign. Then we immediately do 1, because reverse is false. So 1 minus, right? 1 minus this entire thing getting together. Okay, so how about here, right? How about just print this? Print I and this. Nah, not you. Just you. Print I is 13. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And minus, right? And then, ooh, that is wrong. Oh, I see. I see the problem. I see the problem. I see the problem. So come out. Oh my god. Okay, hold on. Basically, we say if OP is this, return left times current. If OP is equal to this, return left divided by current. If OP is not these, or definitely not be plus or minus, so if OP is this, then we just return current. How about this? There you go. Now we pass. Now we pass. Okay, same thing. Try the others. All right. We just do one more check. We don't need the operator. So all right, some really complicated. Let's kind of see if it works. Yep, I think it does. Let's go. See how fast it goes. 136. That's pretty bad. 540 days. Okay. Congratulations, it's a award for users for the continual commitment in solving for 300 days. Check out the badge in the profile page and wear with glory. Only 0.12% have won this badge. We are consistent, that is for sure. This is something, I mean, when you're not that smart, the only thing you can do is being consistent. It can compensate a little bit. Oh, look at that. How do I wear this? Oh, that'd be fun. So, I don't see the badge. Oh, annual badge. Let's wear this one. All right. That is my new badge. Oh, one more thing. I'm not able to do the challenge today because I need to pick up someone later today. So that's a bummer. But it's fine. All right. So it's terrible, right? It's terrible. This is LeetCode 221. I feel like I didn't improve because I forgot what was the. Well, I forgot how I solved this problem in the past. The solution below feels contrived. Yeah, feels contrived. Well, the basic idea is since there is no parentheses, any multiply and divide can be computed immediately. For plus and minus sign, for plus minus, I use recursion to obtain the right-hand side, right? The right-hand side. I mean, overall, it's. I can just say if OP, right? Because if OP, then I return this. If OP is equal to this, else left current, right? Not OP, then we return this. Yeah, it still pass. Return current. For plus or minus, I use recursion to obtain the right-hand side. And there are a few obstacles, right? Obstacles to jump through. For instance, when to transfer, right? When to transfer the value in current to left, and what to return when the traversal of S has ended. But overall, this is going to be ON solution, and we hit a not so glamorous 136 milliseconds, or a 18% ranking. Not very bad. All right, so let's take a look. I'm thinking this probably is the good one. These might be eval, which we don't want. I'm pretty sure what this one is. This one is adding parentheses. I'm pretty sure. Oh boy, I'm not sure. Maybe someday I'll do this. Adding parentheses. What are you gonna do when you add parentheses? Well, you add parentheses. It basically if you add parentheses, ooh, that is a different problem. If you add parentheses. I mean, hold on. No. If you add parentheses, right, we will reuse this result. And the problem just become, we get the parentheses, we pop out everything inside the parentheses, and then we compute by this. All right, take a look. 124 was this is simpler. All right, want to take a closer look later on. Get number. Okay. These are the fast ones. I think it's eval. Oh no, that's not eval. My goodness, this is good. All right, I'm gonna take a look at this. Okay, so I think I'm gonna take a look at this. All right. Now this is my solution, I think. Oh, negative value. Put negative to the numbers to form negative. I remember this. So if I have a negative, I just append a negative value. Huh. How do you reason that? So 1 minus 3 minus 2 was 1 plus minus 3 plus minus 2. Oh. Oh, yeah. Okay. Okay, we get a value. We'll get a value. If it's this, we get an operator. We get a value. And then previous. Oh wow, this is so much easier. So much easier. Oh my god. Okay, space optimized. Previous operation. A letter in S plus this. If it's digit, current N. That's a better one. Aleph is in this. If it's in this, result plus equal to the previous N. Previous N equals current N if this. Else, which means it's this, previous N and equal to this, if this, else this. Alright, let me go through this one more time. So we go through one by one, right? We get the current value, so we get the current value, and now we hit the first value, plus or minus. And when we hit the first value, plus minus, and if it's and then we result, we're gonna add the previous one, okay, and the previous one will equal to the current one if the operator is a plus sign, or a negative value if it's a negative sign. Okay, and operator will become this. Hold on, what are you saying? The result will equal to this one, right? And the operator, now this is the previous operator. That's why I said it's a previous operator. So we go through, and the first time is a plus, an operator we start, the previous operator is a plus sign, which is fine. So we get the result. The result is the left-hand side, right? And that's it. So operator now is a plus. And the previous value is equal to the current value. No, the result, previous value is 0, so the current result is 0, right? And the previous value becomes the current value. That's the left-hand side. Okay, that's good. So we go back up, and it's integer, blah, 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 blah. We get a right-hand side, okay? So we get a right-hand side, all right? So we get a right-hand side, and operator, previous operator is a plus, okay? So previous operator is a plus. Result at a previous one, so result is the previous, and the previous equals to the current. So basically we get a value, we put it into result, right? And now we get a new value, we assign this as the previous. And every time result gonna plus the previous. So previous basically was to compute the remaining values, okay? All right, so previous, we have a previous. And now, next time, if it's multiply, if it's whatnot, then the previous value, because the previous value is a combination of the remainder value for this operator. And we're gonna always do plus to the result, okay? So the previous value will equal to the current value if the operator, the previous operator, is a plus. Okay, the previous operator is a plus, then I will become this one. Otherwise, I'll become a negative value, okay? So we keep going now. Because I am at, okay, hold on. This is the previous one we're looking at here. So we handle this, this becomes the previous value. And now this is the current operator. And we say, okay, so if next one, we obtain a new value, and the previous operator now is, and then we have to combine these two, right? We combine these two, and they become the previous value again. Okay, and then if it's a plus, so if every time the previous operator is a plus, right, that means we have the pre-value have been completely computed. Like if it's a plus or negative, that means it's been completely computed, so I can, oh my god, this is so good. This is so good. This one's not bad. This one is not bad either, right? So basically, yeah, I mean it's not bad either. It's just when, all right, let's see if we can write this. All right, let's try the good solution. So this is the good solution. So this is the good solution from my previous attempt in, when was that? A year ago. I think I used 11/20, 11/24. Okay, so what we're saying is we're gonna have a current value and I like to say a left, current, and OP. 0, 0, and open a star with a plus, right? Just to make it work. And we basically say for I in range, line S, right? Okay. Now we say if si dot is digit current plus equal to current times 10 plus int si. Okay. Else if si is in plus minus, I can just say if si is not equal to, right? It's not equal to an empty space, right? If it's not equal to empty space, then it means it's an operator, right? Now, when we face an operator, yeah, we're gonna also say again, OP is the previous operator. All right. So when we come out, then we just say if OP is in plus or minus, right? That means the previous operator is a plus or minus. All right, so the previous operator is a plus or minus. So I'm at a new operator right now. Right? I am at a new operator right now, and I have a current value, and I have the pre. This is that pre will be easier to understand. There's a pre-value. I have a pre-value, and then I have a current value, and I have a current value, pre-value, current value, previous operator, and a current operator. So I have 4 things. Okay, 4 things. So I'm stopped at a current operator, and I have a previous value, I have a previous operator, and the current value. So with that in mind, right, because the previous operator is a plus, that means the pre-value has ended. It's as no more. So we're going to say no more operation is needed for pre. Therefore, we can go result to have a result, and therefore we can go res plus equal to pre. Right? If its operator is in this. Now, after we do that, then we need to assign a new pre-value. So pre-value will equal to, now that is going to depend, right, on the operator. So if the operator is a plus, then the current value is going to be plus. So pre equal to current if OP is equal to a plus, else negative current. Let's turn all minus sign turn to negative. How should I say this? Deduction turn into addition of negative values. All right, so that's the pre. That's it. That's done. We're done. Else, right? Now, else OP is going to equal to the plus multiply or divide. If it's a multiply or divide, right? If it's a multiply, that's the previous value is multiply or divide. And I have a current, and then we just say pre will equal to pre times current if OP is equal to multiply, else pre divided by current. All right? That's just to update the pre-value. So I have a pre, and then I have this as a multiply, and I have a current. I combine them, become the new pre-value. All right. Once you are done, OP will equal to, I see why I say letter, because there's no need for I. All right, so this is just a letter. Yeah, now makes more sense, letter. All right, so OP equals letter. right? And then what? And then, well, current, because I finished the current. Pre, combine, pre, whatever. So current should equal to 0. So we need a new round, right? A new round. So this one, blah, blah, blah. Once we're done, we're going to return what? Well, at the end, right? At the end, res will equal to, I want to return res, but because if I have a last value, right, and come out, because the end add values, so negative value, then we need to, depending on the operation, we need to do a compute. That's why I add a plus sign, right? If I add a plus sign, then the last value is going to be here, right? Last value is going to be here, and because we have a plus sign, the current is a plus, and then we have a current value, and then rest gonna, whatnot, doesn't matter. We have a pre, right? We have a pre that is good, and and what happens if I have a plus sign? So current is here, right? And then OP is going to be letter. OP is going to be this. OP is going to be this. And OP is going to be this. Current is because 0, right? Maybe we should do this, plus 0. So at the end, we got a plus sign, right? Wait, hold on. We got a plus sign, right? So the last one letter is a plus sign, and then we're going back up, and what do we return? It shall be whatever is the result, right? What do we return? Operator. Now the current value is plus, right? The current value is plus. So we hit here, and whatever operator we have, and if it's not this sign, it's just going to be this. And operator can be a plus sign. Current is this. Going back up, we got nothing. No more. We got no more. So in that case, pre is the thing that's not being done, right? And shouldn't we return rest plus pre? What if we say plus 0? If we say plus 0, right, and then we have plus sign, operator, current 0, coming back up, and then this one, I do this, and we'll come back up again. I feel like we should do this. Then we can just return the rest. Nope. That's not right. Huh. I think I didn't quite understand the whole thing. Hold on, let me think again. So it's the current. But if I add 1, right, then we'll hit again, then we're going to check. And just see how this one goes. It doesn't go very well. First one didn't work. Only equals 3. Alright, so it's because rest is this, right? And then plus sign, that's the operator. So 3 goes inside, right? And the operator now is this. Pre is equal to 2. Current is 2, right? Current is 2. Operator is this. Pre is 3, right? And then the current pointing here. So rest plus equal to this, right? OP is this, so pre now is 2, okay? Operator is this, going up. Now current is 2, okay? Now going up again, operator, so current is pointing to this plus. So operator now is multiplication. So we go here. So pre is equal to 2, right, times 2, so it's 4. So pre is 4, right? Okay, pre is 4. Then operator becomes a plus sign. Current is 0, going up, coming out. So I think what we can do is just rest plus pre, right? But this one's still not right. It's fine. So if letter dot is, oh, SI, what the hell, man? There we go. That's the case. Okay, let's try this. Run this. All right. Yeah, I think this is the same. Uh-oh. Uh-oh. We got a problem. We got a problem. 14, hold on. 14 minus 3 divided by 2 shall be 13. Got 12. Why? Well, I mean, it's a minus sign, right? If it's a minus sign, then pre equal to minus 3. Oh, shoot. Are you telling me I can just use Python for this? Minus 3. Ah, that's why. No, single division. That's why. Ah, I was thinking why you don't use this. Ah, I see now. I see. Again, check everything else, make sure everything works. Yep. Yeah, this is good. So, double check on the result. Yeah, now it's right. So, 2 things, right? A couple things. First, OP points to the previous operator. Pre points to the value to the left of OP. Current points to the value to the right of OP. Thus, and we check OP whenever the current letter hits an operator. Now, if OP is plus, right, or minus, right? If it's a plus or minus, that means the pre-value has ended its journey, and we can add it to result. Also, since we convert all minus operation, no, so subtraction to addition of negative value when combining into rest, we always perform addition. Now then, based on OP being positive or negative, we reassign pre based on current. If, however, OP is this or this, right? If it's operating this or this, then pre's journey has not ended. We combine current with pre based on OP to create a new pre. Yeah. This one is also ON, but it's way faster. We run this at, I think this was like 68 milliseconds. That's a good question. I think if you ask me to do it again, I probably still won't be able to figure this one out. But this is the right solution. All right, I guess that's it today. I was trying to do this one, but I don't think we have time. It's already 1 hour. Yeah, we'll do this some other time, unless if it's easy. Nth digit of the infinite integer. Wait, what? The 11th digit of the sequence is 1. Oh, hold on, is a 0. Oh. This actually could be an interesting problem. The nth digit. Yeah, I mean, we can compute how many digits there are. Hold on. You know what? I'm interested. I want to try this. I mean, like I said, I think given an n, right, we shall be able to, like, say, okay, 1-digit value, right? 1 digit is from 1, right? 1 to 9, that is 9 digits. 2 digits, 10 to 99. How many is 10 to 99? It's 90, right? It's 90. So it's 90 times 2, so 180, right? That's 180 digits. 3 is going to be 100 to 999. that gives us 900 times 3, right? And then, so basically, what we have is 9 plus, so it's 9 times 1 plus 90 times 2 plus, so 9 times, hold on, 9 times 1 plus 9 times 10 times 2 plus 9 times 10 to the second times 3 plus 9 times 10 to the third times 4, right? So basically these are all the digits. So we need to first figure out how many digits are we talking about, right? Okay, so we can run a simple program because n is finite. So we just go through and see which one we ended up. So we're gonna have a k, right? It's a k number of digits for the value, and then we'll have a value, a k, which is smaller, and then we want to add a next one which is bigger. So now we can narrow down on the k. So the answer, right, the result is a k digit number. Now with that, then we're gonna minus whatever we have, so we have a remainder, and then with the remainder, we're just gonna go one by one, right? One by one. So that's gonna be from 1, 0, 0, 0, whatever, and then we're gonna see how many, right? So how many of those, once we get it, and then we're gonna end up at a remainder, right? That's the last number. So we got 1, 2, 3, 4, 5, and then boom, the last one. Okay, we can do the last one. The last one, we're gonna pick it out to count, right? Just to count how many, and I count how many. So the quotient, right? So it's gonna be 1. Quotient, if it's 1 times this, it's gonna be this. 2 times this. So quotient minus 1 is the actual value. Quotient minus 1 plus this is the actual value, right? And now we know the next value. So we know the next value. So it's the quotient. So it'll be the 1, blah, blah, 10 to the k power plus quotient. 10 to the kth power plus quotient. Yes. 10 to the kth power plus quotient. And then remainder. So this value, okay, yeah, this one I can do this. I can do this. This is not hard. This one should not be too hard. I have a strategy. Alright, so basically when you say copy, so it's 400. Alrighty. Tengo mucho ánimo por eso. Pienso que puedo resolverlo sin error. Sin error. Alright, so the first one, we're gonna have a k, right? So k, we're gonna start with, we want to see how many digits, right? So k gonna start with 0, right? So the 10 to the k, right? 10 to the k power will tell us the starting point. And then we're going to say s, okay, we're going to say k, s going to be 0, right? And say while s is smaller than n. Is it smaller or smaller equal to? Because I wanted it to jump out. And when we add something more, then that's too much, right? If we add something, what if it's the equal situation? That will be funny. That would be interesting. If I say s is smaller, there's a sum, right, is smaller or equal to, then I will plus one more that is too big. Then I will say it's that one. But we will do, so sum, okay? hold on. So sum is smaller, and then we add the next one. That's too big, right? So I'd say it's smaller equal to, right? And then the remainder will just be 0. Right? Smaller equal to. If s is smaller equal to this, s plus equal to what? Plus equal to 9 times 10 to the k power times k plus 1. K star is 0. So the first one I say is 9 times 10 to the 0, which is 1, times k plus 1, which is 1. So the first one is 9. Second one is 10 to the first power times 2. So yeah, so we keep doing this. K plus equal 1. Once it jump out, so k is the value too big, right? So s is too big. Then we're gonna see the remainder shall equal to s minus this thing, right? Shall equal to s minus this thing. Because so we add this. Oh, hold on. K s plus this, and k increment, and then s is too big. So when I get out, k needs to be minus equal 1. So k need to minus equal 1, right? And that's the one that causes to explode, right? That causes it to explode. Oh, yes, that's what it causes to explode. So k minus equal 1, which give to this, and then s minus this, and then n minus this. So that is the remaining, right? That is the remaining. So for the k, how many is remaining in the k, right? Now apparently, if remain is equal to 0, right? If remain is equal to 0, so there's nothing inside there to go. Then we're just going to return 9, because that means the nth is the last value of the last number of that. That's fine. Else, if we have remaining, right? If we have remaining, then we know the number of digits, right? The number of digits is going to be k plus 1, right? The number of digits is going to be k plus 1. That is the number of digits, which I just realized I can simply do k minus 1 and times k, so I don't have to do this. Right? So k is the number of digits. So k is the number of digits. So what do we do? So we need to have a quotient of remainder equals to div mod remainder and k. And we say k is the number of digits for current number. Okay? So the quotient, right? The quotient tell us how many we're going to go forward, right? If the quotient is a 0, which is fine, right? Okay, so the value, so the target value is going to be 10 to the k. K is the number of digits. Oh, shoot. That should be k minus 1, right? Because it's 2 digits have been minus 1. So this one plus quotient is our target value. So what we need to do, turn the target value into an str, and then find the rth, right? So the rth is just going to be r, right? Because if r is 0, what if r is 0? Well, if r, let's consider r is not 0, right? So we have blah, 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 and then we have this value, and r is not 0. R could be like a 1. So that's the first one, right? The first one. So that's actually going to be r minus 1. So what if r is 0? If r is 0, which means we have blah, 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 that's the quotient, right? That's the quotient. And that's not the next one. So we shall return this if r, which means if r is not 0, if r, else if r is 0, then we shall return str 10 k minus 1 plus q minus 1. It's not going to be q, right? It's not going to go quotient. It's q minus 1, the previous value, right? And it's this thing's the last one. All right. Let's see. So we have 3 shall return 3. 11 shall return 0. So these are just too straightforward. And oh my goodness. Oh, I see. I need to turn this into an int. All right, so d equals this, and return int d. Oh, I can just return this. It's fine. I can return int. Actually, I can even do this. All right, I'm gonna be cheeky. Okay. Now we're gonna talk. 1, 2, 3, 4, 5, 6, 7, 8. How about this? That is correct. 9, 10. I'm not sure. Some random numbers. All right, I'm gonna test 2 more. Let's test on the edge. 9. Test the edge. Okay. Try another edge. Let's try 189. That is edge. Okay. Let's try 189, 90, 91, and 92. 192. That shall be a 0. It's a 100. The value is 100. All right. We can try it. Booyah! We got it. So, yep. So the analysis was correct. Well, this is not a difficult problem because it can be solved via analysis. So first of all, we need to pinpoint the number of digits the target value has. To do this, we run a loop to check at which number of digits the total sum of digits exceed n, right? Then after we obtain the number of digits for the target value, we compute, right, the number of digits going from 10 to the k minus 1, the number of digits after we obtain a number of digits k, right, then we compute the number of digits going from this to our target value. Then we compute we compute the number of digits. Let's call that rem. After that, we compute div mod ram with k, right? This tells us how many k-digit numbers are there from 10 to the k minus 1 to our target values. So the number, in other words, our target value is 10 to the k minus 1 plus q. Finally, the target digit is the r minus 1th compute this one equals qr. We need to say what q and r is, right? And then in other words, blah 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 is this digit in the str version of the target value. Now two potholes. First is when ram equals 0, and the second is when r equals 0. They need to be treated separately. Ram equals 0 means the nth digit is the last digit of the last number of k minus 1 number of k minus 1 digit number, which is always 9. R equals to 0 means the nth digit is the last digit of 10 to the k minus 1 plus q minus 1. Right, so these are the two things you need to worry about. And the runtime basically is this. I don't even know how to say this. It's just log n. This is log 10 n, right? And we run at 32. I'm pretty sure somebody might have a pure math solution for this. It's possible. So I just see the discussion. Java solution. Okay, I'm gonna read, and read. Oh, it was labeled easy. That was easy. This frustrates. 2019. Nah, it's definitely not hard. I mean, easy. I can see it's not an easy problem. It's a medium problem. It's a medium easy problem. Right? There's no trick. Right? There's no there's like 2 tricks. That's it. But a straightforward analysis can solve this problem. All right, yeah, that will be it. Yeah, I'm not gonna waste time to live stream how I read through those posts, so I'm just gonna